Welcome back, Chemistry 30. So hopefully you had a chance to look at 3B and 3C. Here are the solutions for that. So lead nitrate and potassium bromide are the ones that you put together. So once again, pink sheet, lead 2 is Pb2 plus, nitrate is NO3 minus. So they come together in a 1, and we have to have 2 nitrates there to balance that. 2 positives, -1, and another -1. So we have to have 2 nitrates there. Potassium bromide, K plus, K or Br minus, so they're 1 to 1. So then they switch partners. Lead bromide and potassium, nitrate again. Nitrates are soluble, so that tells you right there that KNO3 is not the precipitate, it's aqueous. So it must be lead 2 bromide. So if you look at lead, it's 2 plus, bromide's -1. So we have to have 2 bromides for every 1 lead, Br2. Put a 2 in front here to get 2 Brs here. That's going to change this to 2 Ks. So we're going to put a 2 there for 2 Ks. That's going to give us 2 nitrates. And hey, we have 2 nitrates. So lead 2 bromide. And I think this is the same part of that chart that we looked at earlier. Bromide, lead 2, PPT. So we can show that by it's not a nitrate, and if there is a precipitate there, that's what it must be. So then breaking it down into the complete ionic equation, and then lastly the net ionic equation, that's what you should have got for B. Okay. Looking at the next question, 3C, sodium sulfate, barium chloride. So let's see here, sodium sulfate, barium chloride. Again, go to your pink sheet. You can't do this unless you know what those ions actually are. Sodium is +1, sulfate is 2 minus, barium is 2 plus, chloride is -1. So making the compounds here, you need to have 2 sodiums to balance the 1 sulfate, because we have 1 positive, 2 negatives, so it's Na2SO4. Barium, you have to have 2 chlorides here to balance the barium, so there we have it. And when they switch partners here, NaCl 1 to 1, so it's just NaCl, and BaSO4, so those are the 2 possibilities. Notice here I have the words alkali metal, so when I form sodium chloride, chloride, I don't see sodium in this list, so sodium must fall in here. No precipitate. Or sodium, you know, is an alkali metal, and alkali metals with any other negative ion, no precipitate. So sodium chloride is not it. The other compound I had was barium sulfate. So sulfate, barium, PPT. So that once again the chart is set up kind of backwards. You look at the negative ion, look at the positive ion that's with it, and then go from there to see what the precipitate is. So barium sulfate is in fact the precipitate. So if we look at that, there we have it. BaSO4 is the solid, so I put an S there. This is aqueous. I have 2 chlorides over here, so I have to put a 2 in front of here to get 2 chlorides. That'll give me 2 sodiums, and hey, I have 2 sodiums over here, so it balances out fine. Then break it up, 2 sodiums, 1 sulfate, 1 barium, 2 chlorides, as you see coming up, 2 sodiums, and then we see we have 2 chlorides here, and then BaSO4. So the net ionic equation is barium ions plus sulfate ions give you barium sulfate. Okay. Next question, number 4. Just simply looking up these compounds. Are they soluble or insoluble? Are they PPTs or not? Sodium hydroxide, sodium acetate, calcium sulfate, lead 2 chloride, potassium chloride, calcium bromide, etc. So you have to just simply look them up. Are these precipitates or not? So changing them to formulas first of all. That's what we get. I'll get you to pause the video now so you can look them up and try to figure them out for yourself. If you had time to look at it, sodium hydroxide, notice here I have written that sodium is an alkali metal. Alkali metals are soluble. So if you recall over here, alkali metals, sodium in anything is soluble. Okay, and the next one we had was ammonium, I believe. Ammonium acetate, NH4, C2H3O2. So have a look at where that is on there. The acetate ion with everything is soluble except silver. There's a precipitate. So in this case, that is soluble as well. Calcium sulfate, hey, that's one we just did up here, I believe. No, barium sulfate we did. So calcium sulfate, if you look here, sulfate combined with calcium, PPT. So we have some PPT action there. Lead chloride is one we did earlier as well. I think that one's up here somewhere. Oh, I guess we did lead bromide, so we should check it out. Lead chloride, lead 2 chloride, chloride combined with lead 2, PPT. Okay. Potassium chloride. Again, potassium is an alkali metal, a group 1 metal, so it is always soluble. Calcium bromide is soluble as well. You should check it out here. Bromide combined with calcium. So bromide, I don't see calcium in this list, so it must be here under the heading of any other cation. It's soluble. Okay. So next here, that's number 4. Number 5, if we look back at the question sheet, what's that all about? Why are spectator ions deleted from the net ionic equation? If we look there, of course, the spectator ions do not participate in the formation of the precipitate, so they're not included. Okay? Just simply that. Okay, so that's brings us to the end of all the questions we're doing together. The questions I'm going to assign for you is number 6, 7, 8, but I'm going to do one of each so you know how to do it. We are going to omit some here. We're going to omit 6A, so you can cross this one out. 6D, you can cross that one out. And 6G, I believe you can cross that one out. Okay, so all those ones we are simply not going to do. So 6A, cross out. 6D, cross out. 6G, cross out. Okay? So I'm going to do B with you right now, and then that'll leave you C, E, F, H, I, J, K, L for you to hand in. So it's simply here, use the table, determine which is the precipitate, write the balanced chemical equation, then I want you to change it to complete ionic equation, then finally net ionic equation. So here we have lead acetate, C2H3O2, and potassium sulfate. So we'll go with that and figure out what the precipitate is and go through the process to figure that out. Okay, so here we go. So the ions, again, your pink sheet there. Oh, I think I did the wrong one here. Let's see here. Bismuth nitrate is what I wanted. 6B, yeah, so I'm actually going to do 6B with you here. So bismuth nitrate, sodium hydroxide. Notice that we have 3 nitrates here, so that implies that this bismuth ion must be plus 3 as a charge, because we need 3 nitrates with it. So that kind of gives you a hint. Even though bismuth isn't on the pink sheet, it tells you what the charge must be. Since we need 3 of these to balance a bismuth, it must be bismuth 3. Sodium hydroxide, NaOH, that's relatively straightforward. So if we take a look at what the options are, bismuth hydroxide. So if I look back, bismuth hydroxide, or hydroxide with bismuth. So let's look at, there's 3 options here. Alkali ions, bismuth is not an alkali. It's not a group 1. Alkali metals, recall, are these ones here. So it's not that. It's not that. It's not in this list. So therefore it must be any other cation, which of course is not soluble. So that in fact is the PPT. That's the precipitate. And of course, if we look carefully here, the other combination of sodium nitrate, look at that, it's a nitrate. And if you recall up here, nitrates are soluble. So that tells us that bismuth hydroxide. And again, 3 plus, 1 minus, I have to have 3 hydroxides to balance that out. NaNO3 plus 1 minus 1, they come together as NaNO3. Then you worry about balancing it. I have 3 hydroxides, so I have to put a 3 in front of here to make 3 hydroxides. That's going to give me 3 sodiums. So I got to put a 3 in front of here to get 3 sodiums. That's then going to give me 3 nitrates, and lo and behold, I have 3 nitrates over there. Okay, then breaking that down into ion form, if we take a look there, we have 1 bismuth and 3 nitrates. So it breaks down to that. 3 sodiums, 3 hydroxides. Bismuth hydroxide stays as the PPT. 3 sodiums, 3 nitrates. So you can see the ions that we cross off there, because they're just spectators. 3Na, 3Na, 3NO3, 3NO3. And of course, that leaves you with the precipitate and the ions that made the precipitate. Okay, that's into part 2. We'll come back and do number 7 and 8. See you soon.